Fiber and muscle growth are central topics in exercise physiology, muscle biology, and sports science. Muscle growth, also known as hypertrophy, involves complex processes at the cellular level that result in an increase in muscle size. Here's a detailed overview of the relationship between muscle fibers and muscle growth. Muscle fiber type S. Muscle fibers can be classified into different types, primarily based on their contraction speed and fatigue resistance. Type I slow twitch fibers, also known as oxidative fibers, adapted for endurance and continuous, low-intensity activity. High mitochondrial density and myoglobin content. Slow to fatigue and capable of sustained contractions. Type 2 fast twitch fibers, further subdivided into Type I fast oxidative glycolytic and Type X fast glycolytic fibers. Type I, intermediate between Type I and Type X, with both aerobic and anaerobic capabilities. Type X, primarily anaerobic, adapted for short bursts of power and speed, fatigues quickly. Mechanisms of muscle growth. Muscle growth occurs through several mechanisms. Hello friend, welcome to my channel. It's great to have you here. Please subscribe and like and comment. Thank you. Mechanical tension. Lifting heavy weights generates mechanical tension in the muscle fibers. This tension is sensed by mechanoreceptors, which activate signaling pathways that lead to muscle growth. Muscle damage. Intense exercise, especially eccentric contractions, causes microscopic damage to muscle fibers. This damage triggers an inflammatory response and the activation of satellite cells, muscle stem cells, which repair and build new muscle tissue. This stress stimulates hypertrophy through the accumulation of metabolites and cell swelling, which may signal the muscle to grow. Role of satellite cells are crucial for muscle repair and growth, located between the basal lamina and the sarcolemma of muscle fibers. Activated by muscle damage, these cells proliferate and differentiate into myoblasts, which fuse with existing muscle fibers to repair damage and contribute to muscle growth. Hypertrophy vs hyperplasia. Muscle growth can occur through hypertrophy or theoretically hyperplasia. Hypertrophy. Increase in the size of existing muscle fibers. Hyperplasia. Increase in the number of muscle fibers. While this is more controversial and less understood in humans, some animal studies suggest it may occur under specific conditions. Training for muscle growth. Different training protocols can preferentially target different muscle fiber types and growth mechanisms. Resistance training. Heavy weights with low repetitions primarily target Type II fibers, enhancing strength and power. Moderate weights with moderate repetitions, for example, 6-12 reps, are often used for hypertrophy, balancing mechanical tension and metabolic stress. Endurance training targets Type I fibers, improving mitochondrial density and oxidative capacity. While not primarily aimed at hypertrophy, can lead to some growth of slow twitch fibers. High-intensity interval training height can target both Type I and Type II fibers, depending on the intensity and duration of intervals. Provides a mix of endurance and resistance benefits. Nutritional and hormonal factors. Muscle growth is also influenced by nutrition and hormones. Protein intake. Adequate protein intake is essential for muscle repair and growth. Amino acids, particularly leucine, play a key role in activating muscle protein synthesis. Hormones. Anabolic hormones like testosterone, growth hormone, and insulin like growth factor 1 IGF-1 promote muscle growth. Cortisol, a catabolic hormone, can hinder muscle growth if chronically elevated. Conclusion. The interaction between muscle fibers and muscle growth mechanisms helps in designing effective training and nutrition programs for athletes and individuals aiming to increase muscle mass. Optimizing mechanical tension, muscle damage, and metabolic stress through varied training protocols, alongside proper nutrition and hormonal support, can maximize muscle hypertrophy and improve overall muscular performance.